A school is sharing 14 care packs among 4 support rooms: the quiet room, the newcomer room, the reading corner, and the wellness room. Each room must get at least 2 packs, and each room may get at most 6 packs. There is a twist. Exactly 2 of the 4 rooms must end with an odd number of packs. How many different ways can the school share them? Pause the video. Try it before I show the trick. Hint: choose which 2 rooms are odd first. Then count what fits. Step 1. Reserve 2 packs for each room. That is the reserved seats move. 14 minus 4 times 2 equals 6 extras. Here is the key. 2 is an even number, so a room ends with an odd total if and only if its extras are odd. The cap matters too. Each room can get at most 6 packs. That means at most 4 extras. Step A. Choose which 2 of the 4 rooms will be the odd ones. 4 choose 2 equals 6. Step B. For one such choice, count the valid distributions. The 2 chosen rooms get odd extras, so 1 or 3. The 2 unchosen rooms get even extras, so 0, 2, or 4. All 4 totals must add up to 6. If the odd pair is 1 and 1, then the even pair must sum to 4. That gives 3 options. If the odd pair is 1 and 3, the even pair sums to 2. 2 options. If 3 and 1, again 2 options. If 3 and 3, the even pair sums to 0. Only 1 option. Add. 3 plus 2 plus 2 plus 1 equals 8 ways per choice. Each of the 6 choices gives 8 ways, so just multiply. Total equals 4 choose 2 times 8. 6 times 8 equals 48. The answer is 48 ways. Nice spotting. This is the choose then pour rule. If a problem says a subset of the rooms must satisfy a property, then choose which rooms first. Use a combination for that choice. Then count the valid distributions within each choice. Multiply the 2 counts. Look for the words exactly k rooms must, or any k of the rooms. That is when this rule applies. Learn, compete, and win. Visit competitivekids.org.